What is going on, guys? My name is Amos and I'm really pleased to be your instructor, and I'm back with yet another video. And in this video we want to look at U-substitution, that is integration by using U-substitution. Now the question is, why using U-substitution? So it is because we have standard integrals and integrals that are not standard integrals. Something like the integral of cosine of u, maybe cosine of x or cosine of u du is a standard integral, and we know that the integral of cosine of u is sine of u. So this is what you would call a standard integral. But there are also some integrals that are not standard integrals. But the question is, how do you solve those integrals? One of the ways is to use U-substitution. We're going to make that integral that is not standard, we're going to make it look like a standard integral. So with this, we're going to look at 6 problems that we are going to solve using U-substitution, and we shall start with the first one. The integral of cosine of 3x plus 7d dx. So what is the integral of cosine of 3x plus 7 dx? Now this is not a standard integral. Something like a standard integral would look like cosine of u. Yep. So we need to substitute this 3x plus 7. So we will let u be equal to 3x plus 7. And then now, when u equals 3x plus 7, what will be du? So du is going to be equal to the derivative of 3x plus 7 is 3, and the derivative of a constant is 0, so this goes to 0. Now here we've differentiated with respect to x. So I'm just going to put my dx. So we'll substitute this 3x plus 7 and this dx. Alright, so this du divided by 3 is going to be equal to d dx. Alright, so this integral is equal to the integral of cosine of u. Now the dx is du divided by 3. Now this is also equal to, 1 over 3 is a constant, so we can take it out of the integral sign. So this should leave us with cosine of u du. Now this is a standard integral. This is going to be equal to what is cosine? The integral of cosine of u. The integral of cosine of u is sine of u. Okay, the integral of cosine of u is definitely sine of u. Now after going through this process, we need to resubstitute. And what was u? U is 3x plus 7. So we have 1 over 3 sine of 3x plus 7. So that is your integral. Let us look at another example of U-substitution. So we want to look at the integral of 2x minus 5 to the power of 7 dx. So we need to substitute the 2x minus 5. All right, so we'll let u be equal to 2x minus 5, and we'll need to replace the 2x minus 5 and the dx. So du is going to be equal to 2d dx. All right, this means that du divided by 2 is going to be equal to dx. So this integral is equal to u to the power of 7, and what is our dx? Our dx is du divided by 2. Now the 1 over 2 is a constant, so we can take it out of the integral. This should leave us with u to the power of 7 du. This is equal to 1 over 2 u to the power of 7 du. Now the integral of u to the power of 7 is, now it is u to the power 7 plus 1 over 7 plus 1, and this is half. U to the power 7 plus 1 is u to the power 8 over 8. Now this is 1 over 16 u to the power 8 and we resubstitute. So what is our u? Our u is, our u is 2x minus 5. So we shall have 2x minus 5 to the power of 8. So we are done with this problem. So we look at another example of u substitution. We're going to do 6 problems. We've already done 2. So we only have 4 problems to go. And we have the integral of 4 over that is 5x minus 3 dx. Now we have to substitute this 5x minus 3. So we'll let u be equal to 5x minus 3. Therefore, du is equal to 5 dx. And the du divided by 5 is equal to d dx. So this is equal to, this integral is equal to the integral of 4 divided by u multiplied by du over 5. And this is equal to, all right, so this 4 over 5 is a constant, so we can take it out of the integral, and this should leave us with 1 over u du. All right, so this is like a 4 over 5. The integral of 1 over u is natural log of the absolute value of u. And now this is equal to 4 over 5. We resubstitute natural log of what is our u, or our u was 5x minus 3. So we put it in absolute values. So 5x minus 3, which we put in absolute values. And now absolute values. This means that we are done with this problem. Oh, and of course, we need to add the constant of integration. Even for the previous problems, if I didn't add, you have to put that plus c. All right, because this is not a definite integral with bounds with which you can replace the value of x here. So you can add that plus c, the constant of integration. And we need to look at another problem of u substitution. I actually rubbed out the title, so let me just take all of it. And we go to the fourth problem. The fourth problem, the integral of 2 e to the power 6x minus 1. So what is this equal to? So you see that we need now to replace this, the 6x minus 1. So we'll let u be equal to 6x minus 1. So du is equal to 6 dx. And this means that u over 6 is equal to d to dx. So that is simple. So now this changes to, now when x is equal to 0, u is equal to, when x is equal to 0, u is going to be equal to 6 multiplied by 0 minus 1. Therefore, u will be equal to minus 1. So we shall have minus 1 as the lower bound. So when x goes to 1, u is going to be 6 multiplied by 1 minus 1. U will then be equal to 6 times 1 is 6 minus 1 is 5. So we are going to have a 5 here. And of course, this is going to be 2 e to the power of u multiplied by the dx is du over 6 multiplied by du over 6. Now the 2 into 2 is 1, the 2 into 6 is 3, and the 1 over 3 is a constant, so we can take it out of the integral. So we shall have e to the power u. Okay, and then now we know that the integral of e to the power u is e to the power u. Now this has to be equal to 1 over 3. We shall have e to the power u and 5 and minus 1. Now this is going to be 1 over 3 e to the power of 5 minus 1 over 3 e to the power of minus 1. And we are done with this problem. Now we look at the fifth problem. Now look at the fifth problem. We're basically done with this one. So U-substitution is really simple. It's not that bad. Now it also depends on what you're given as problem. So here we need to show that the integral of tan theta d theta is equal to natural log of sec of theta plus c. All right. So to start off, we need to note that tan theta, we know that tan or tangent of theta is equal to sine of theta over cosine of theta. All right. So that's the first substitution we are going to make. Now this is sine of theta over cosine of theta d theta. Now what we have here is expressed as we have the top part, which is our numerator sine of theta, and our denominator, which is cosine of theta. Now if you really look at this, what is the derivative of cosine of theta? The derivative of cosine of theta is minus sine of theta. All right, we want to express this in the form u prime over u. All right, where u is our function, that is in this case cosine of u. We need the top part to be u prime. This is sine. We know that the derivative of cosine of theta is minus sine. So this is equal to minus cosine of theta prime over cosine of theta. If you differentiate cosine of theta, you'll get minus sine theta. Minus sine theta times the minus that is here, you get back to the original function. And then now we know that when we have u prime over u and we want to take the integral of u prime over u is natural log of u. So that is simple. So we make that substitution. So this is the minus sign here is a constant, so we can take it out of the integral. That is we can take out minus 1. So we have cosine theta prime over cos theta. Now you will let your u be equal to cos theta. This is just for reference. We're not going to make any dx and cos u sub. This is just for reference, so that you can easily visualize what you have here as u prime over u. All right. So this is going to give us what? This is going to give us minus natural log of the absolute value of cosine of theta. Now let's assume that we take theta. If we assume that theta is always positive, that's when we can take out these absolute values. So if we make that, if we suppose that that is true, then we can safely take out the absolute values. All right. Then, by the laws of logarithms, we know that we can do this. Cosine of theta raised to the power minus 1. Now, ln natural log of cosine of theta raised to the power minus 1. Now, this is the same as having, let's imagine that you have ln or natural log of, let's say, x to the power negative 1. Something like x to the power negative 1. Then you know that x to the power negative 1 is natural log of 1 over x. It's still the same thing. So here we shall have natural log of 1 over cosine of theta. So 1 over cosine of theta is what is known as sec of theta plus the constant of integration. Thank you guys for watching, and I'll see you next time.